Let's have a look at the perpendicular distance formula. And the shortest distance from a point to a line is the perpendicular distance. Obviously, if I just say to you, how far away is this line, or this point, sorry, to this line, or from here to the wall, there's lots of different distances that I could pick. So it's just understood to be meant that when we say the distance from a point to a line, we're talking about the shortest distance, which is the perpendicular distance. So there's my random point, which I'll just call x1, y1, and random line in general form. So we're trying to find that perpendicular distance there. Our formula turns out to be the absolute value of, and it's quite an easy one to remember because the top of the fraction, if you look at it, is just the general form of the line, but we've substituted the point in, x1, y1. And on the bottom is basically Pythagoras' theorem. So square root of a squared plus b squared, where a and b are the coefficients of the x and y. Now it needs to be absolute value because depending on which side of the line you are, it will be positive or negative on one side. I'll explain a bit more about that in a sec. So all right, we're going to find the equation of a circle with tangent 3x minus 4y minus 12 equals 0 and centre 1, 4. You might think, well, this is a rather odd question to have when we're talking about perpendicular distance. But if you remember some circle geometry, you remember that the radius is always perpendicular to the tangent at the point of contact. So in fact, what they're really asking me to find here is, first of all, let's find the length of the radius. Right? So it'll be the perpendicular distance from the centre of my circle, which is 1, 4, to our particular line there. Let's find it. So absolute value, the equation of the line in general form, substituting the point 1, 4 over the square root, and then it's Pythagoras' theorem with the coefficients of x and y, so 3 squared and minus 4 squared. This one tidies up quite nicely. I get 25 on top, square root of 25 on the bottom, so I just end up with 5 units. I know the centre, I know the radius, so therefore we can write down the equation of our circle. It'll be x minus the x coordinate of the centre plus y minus the y coordinate of the centre is equal to 25. This also gives me a way of telling whether a line will cut the circle, touch the circle, or miss the circle altogether. Right? Because if I was to find the perpendicular distance from the point to this line, okay, in this case it worked out to be the same as the radius, so I know it's a tangent. But if that distance was less than the radius, then the line must cut through the circle in 2 spots. And if it was more than the radius, then the line must be further away and doesn't touch the circle at all. So we can also use the perpendicular distance for that sort of question. This is what I was saying before, is the reason we have absolute value is because this general form, when we substitute the point in, will have different signs depending on which side of the line we are. And that all comes back to regions in the plane. Because if I said to you, hey, shade when ax plus by plus c is greater than 0, well, the line would be the boundary, and then on one side of the line we would have shaded it. So clearly when I substitute in anything over here on the right-hand side, I'm going to get a positive number. But if I was on the left-hand side, I would end up with a negative number. So I guess that's also a way of telling whether points are on the same side of a line or on opposite sides of the line. We can substitute the point into the equation in general form. If they both come up positive or both come up negative, we know they're on the same side of the line. If one's positive, one's negative, well, we know they're on opposite sides of the line. So that's another use for this perpendicular distance idea. Okay, let's have a go at 5e.